Hello, I'm Matthew, and today we'll talk about the effectiveness of the COVID vaccine. So I heard on the radio a couple days ago when someone was asked why he wasn't getting vaccinated, he replied, "I don't think the vaccine is as good as they say." His comment got me curious, and as a mathematician, I wanted to investigate the real-life statistics of COVID-19 and confirm the vaccine's effectiveness myself using the most recent data. Here's a disclaimer. You only need a grade 9 level of math, but also a teacher level of patience. I'm guessing that the type of data that the person saw was something like this. This is the percentage of the hospitalization in BC, Canada due to the COVID infection in the second half of the September 2021. As you can see, the unvaccinated take about 71% of the hospitalization, when fully vaccinated take about 19%. Just by looking at this data alone, you can see the effectiveness of the vaccine, but perhaps it doesn't look as effective as you imagined. True that there are more unvaccinated in the hospital, but aren't COVID vaccines supposed to have an efficacy of 90+%? In order to understand the full picture, there is another set of data you need to take into consideration. The percentage of vaccination. If you look at the left chart, you can see that more than 80% of BC population with an age of 12 and older are vaccinated. And it is this 80% of the people that only make up for the 19% of the hospitalization. On the other hand, this 12% of unvaccinated make up for the over 70% of the hospitalization. Now it's time to apply our grade 9 math concepts and calculate the exact number for the vaccine efficacy. What we're going to do here is to use the concept of ratio and compare the risk of the fully vaccinated with the risk of the unvaccinated. The key equation we'll be using is over here. Population of a group multiplied by their risk of infection gives you the number for the group's hospitalization. Let's define our variables. First, for the hospitalization, let H represent the total number of the hospitalized COVID patients. We could use the exact number, but because this number will later cancel out, we'll just keep it as H. H full represents the number of the hospitalization of the fully vaccinated. Since the fully vaccinated take 19.2% of the total hospitalization, H full is equal to 0.192 times H. And that is how the hospitalization of the partially vaccinated is 0.099H, and H naught, the hospitalization of the non-vaccinated, is 0.709H. The same idea applies to the vaccinated population. We'll let P represent the total population of BC, and since the percentage of the fully vaccinated is 80.8%, population of the fully vaccinated is equal to 0.808p, and the rest follows. Now let's use our key equation to find our risk factor. Population of the fully vaccinated times the risk of the fully vaccinated is equal to the hospitalization of the fully vaccinated. Let's substitute the values for P full and H full from the left side. And then we divide both sides by 0.808p to isolate our variable, the risk of the fully vaccinated. And as a result, we get this as our risk factor for the fully vaccinated. I know that we still have variable h and p in our equation, but since they will get cancelled out once we compare this with the risk of the unvaccinated, we'll move on for now. Following the same procedure, we set up our key equation and substitute and isolate the variable to get this as the result. Okay, we're almost there. All we need to do from here is to find the ratio of the risk of the fully vaccinated to the risk of the not vaccinated. We'll use a fraction to express this ratio. That means that we will calculate the risk of the fully vaccinated over the risk of the not vaccinated. We substitute our numbers from above, and you will see that we have h over p both in the top and the bottom of the fraction, so they will cancel out. Now, we use a calculator to plug in all the numbers, and we get approximately 1 over 24.6, meaning that the risk of the not vaccinated is 24.6 times greater than the fully vaccinated. This in percent is 4.1, meaning that in a situation when 100 of the non-vaccinated gets the infection, only about 4 people of the fully vaccinated will get the infection. In other words, the fully vaccinated are 24.6 times more protected. This in vaccine efficacy is 95.9%. If you do the same calculation for the partially vaccinated, you will find that they are 4.2 times more protected against COVID-19 than not vaccinated, and they have 76.3% of the vaccine efficacy. If you want to see the Excel sheet that I created for all the calculation, please check out the link in the description below. So the numbers look solid, but in case you are still skeptical, I did the same calculation using the data for the first half of the September 2021, and I found 97% of the vaccine efficacy for the fully vaccinated and 87.4% for the partially vaccinated. If you think that BC has a higher vaccine efficacy somehow compared to the other places, I did my calculation using the statistics of Saskatchewan where the COVID numbers are spiking right now, and I still found 91.4% of the vaccine efficacy for the fully vaccinated. In summary, I was able to confirm that the COVID vaccines are about as effective in real life as they claimed. The full vaccination gives over 90% of the vaccine efficacy consistently, and the partial vaccination gives over 70% of the vaccine efficacy. After creating this chart, I thought some people could still be skeptical, thinking that the number that was used for the calculation was the number for the hospitalization and not infection. So I did more calculation, and this is the result. Still consistently giving over 90% efficacy for the full vaccination and over 70% for partial vaccination. The Chief Medical Officer of BC, Dr. Bonnie Henry, has said that the science is clear. And let me add, the math is also clear. I hope you found this video helpful. If you did, please hit the like button and subscribe. I'm Matthew, and I'll see you in the next video. Bye!